All right, hello and welcome. We're going to talk about weather. So get out your notebook, and we're going to call this, you can ignore this up here. We're going to call this 7.1, and this is the makeup of the atmosphere. Okay, so the atmosphere, right? We got all the air, and like we talked about before, excuse me, it gets thinner the higher you go up. But it's not quite that simple, okay? There's a lot more going on. Obviously, there's wind moving things around. So when we're talking about weather, there's kind of a lot to it. So we're going to spend quite a bit of time talking about weather and weather reports. But today we're just going to talk about what is weather, what causes it, stuff like that. Sort of an introduction to weather, okay? What is the atmosphere? What's it made of? We have to understand. So I'll tell you we need to write stuff down. Just make sure you have your notebook out. Right, it's air, it's gas surrounding the planet, gravity's holding it in place, and it goes up to 350 miles, but we really just have to worry about the bottom slice for what we'll be flying in. All right, so one thing you need to know is that water is a big part of weather and how much humidity is in the air. And a big part of why we get thunderstorms in the summer is because warm air can hold more water than cold air, okay? And another fact is water vapor is less dense than air, which is why when we talk about density altitude, that came into play. But the big thing is warm air moving in and cooling down is what causes those big storms, okay? Those cold fronts moving in, which we'll get into more, okay? But warm air can hold more moisture. And this is fact numero uno, okay? Most important thing, every weather process is a result of heat exchange, okay? So anytime something happens with the weather, it's because something was heated unevenly, okay? And then it has to exchange hot to cold in order to kind of even things out, okay? That's why we have all that movement. Okay, so I just said it, but what causes all weather? That is heat. So this is what you for sure need to write down. So we got heat exchange. Make sure you're writing this down. And what does that mean when we say heat exchange? Okay, essentially, when the Earth is heated by the sun, it's uneven, right? It's a globe. It's a sphere, and there's clouds and mountains. So it's because of uneven heating of the Earth. Somehow perfectly heat everything the exact same temperature, there would be pretty much no weather. Okay, obviously that's not the case. Okay, when air is heated, it wants to move. Okay, and specifically, what we're worried about is when hot air wants to rise. Okay, so the sun will heat something up, and then it won't want to stay there because it no longer equals the pressure around it. So it's going to want to rise because it becomes lower pressure. All right, so it's a bit backwards from what you think, and maybe we'll write this down. So hot air or warm air will have, so I would guess if the air gets warmed up, it's going to have low pressure. High temp, low pressure, okay? It's easy to get those things mixed up, but that's where we get the low pressure systems from. Okay? So if you hear the weatherman talking about a low pressure system moving in, he's talking about warm air. Typically, there can be other situations, but typically it's just warm air. All right, when air cools and forms high pressure, so it cools, forms high pressure, it wants to move to where the low pressure is, the warm air. So we say it wants to go toward low pressure. Okay, so those are the most important things, right? Heating causes it. When it's heated, it makes a low pressure, and then all the cold stuff, the high pressure, wants to go right? So we have all this high air. Okay, all of a sudden it gets heated over here. And now it wants to go to that warm spot. Okay, it wants to fill in that void to even out the pressure. And this is pressure we're talking about, okay? High pressure to low pressure. All right, so we have this cycle here. This creates the cycle of the weather, which I don't know, maybe you guys learned about that in science class. Probably something along those lines. And we have the circulating air, which we call convection, which we'll talk about in a second here. Okay, we have layers. We mainly have to worry about the troposphere for what we're talking about. But the stratosphere, planes do fly there, but obviously it's a lot bigger planes that do that type of flying. Okay. Yeah, we don't need to worry about the layers too much. That's the main part for 7.1. Let's look at 7.2. All right, so you can ignore this. This is 7.2, and it's atmospheric circulation and winds. Okay, so now we got the uneven heating, we got high and low pressures. How are things moving? And there's actually a lot of things that make it not as simple as from point A to point B. Okay, a lot of curvy paths because of several things. Okay. So the first thing you need to know is called convection. You don't need to write this down yet. And convection, you probably have heard of a convection oven. This is what it does. It just circulates hot air. But in weather, outside, what's happening is something's heated up. It wants to rise, and then the cool air wants to fill it back in. Okay, so we end up with this circular pattern of the hot air rising. It cools off, comes down, and then wants to fill in the void that was caused before. Okay, so that's exactly what convection is. It's the circulatory action of fluids, gases or liquids, in response to heat. Okay? All right. Right, we said that sun causes this uneven heating, and like I said before, uneven heating drives the weather processes of the Earth. Okay, so here's what you need to write down. Well, okay, let's talk about this first. Speaking of uneven heating, there's a little diagram that shows, okay, some of the energy of the sun gets sucked up by the atmosphere, some gets deflected by clouds, and then a good chunk of it gets absorbed by the surface, and some is reflected, okay? So clouds and the atmosphere, greenhouse gases, can all affect these things, but we don't need to go into too much. Here's what you do need to write down. Convection, what is convection, okay? It's circulating air. And that's as a result of heating. Okay, so it gets heated, goes up, the cooler cools down and fills in the void. Yeah, so we have, okay, so something gets warmed, it goes up, and then eventually, when it gets higher up in the atmosphere, it's colder up there, it cools down, then it wants to sink back down, and it says, hey, there's low pressure here, I want to fill that back in, and it zoops back over, and then we have a cycle, okay? All right, uneven heating of the surface, Earth's surface causes all weather events. Okay, emphasis on all. Okay, it's the uneven heating. Yeah. So just to clarify, so the when things are heated, it creates that low pressure. Okay. So the heating. Let's say it like this. The heating creates low pressure pockets. And cool air, which is high pressure, rushes to the low pressure. So if we were to draw this with pressure, we would have that same picture. We have low pressure. If low pressure wants to go up, And then it cools off and becomes higher pressure. Okay, now that it's higher pressure, it doesn't want to be as high up anymore. It belongs closer to the ground. So it sinks back down, and then it wants to rush back over to fill that pocket of low pressure. All right, so same thing, warm and cool, low and high, same idea. Okay, it's easy to get these mixed up. Remember, warm air is low pressure. Cold air is high pressure. All right, yeah, that's all for that. All right, thermals, not as much to say about that. If you fly through the warm rising air, you're going to get more lift. The rising air is going to push you up. Don't have to talk too much about that. This we do, okay? This affects weather patterns a lot because they're not going to go in a straight line, okay? And this has to do with something called the Coriolis effect, which we'll talk about in a second here. Let me find where I had that. But essentially what happens is when the air goes up, okay, it sucks in air from around it in sort of a spiral. And because the Earth is rotating and the weather patterns, it's very consistent the way it rotates, okay? So let's first talk about what the Coriolis effect is, okay? So let's get rid of this. I don't need this high-low pressure. We already talked about that. Let's get rid of that. Okay, what is the Coriolis effect? Okay, so what's going to happen is the winds are going to be flowing in curved lines. As a result of the Earth rotating. Probably spell that right. Rotating. Okay, so we have the Earth. The Earth is spinning, and you can kind of think of it like it's sort of dragging the air with it as it spins. Okay, making it so that the air wants to go straight, maybe it wants to go straight north to south. As it's spinning, it sort of pulls it along this curved path. Okay, so what does that mean? Okay, so we have two things that happen with high and low pressure pockets. So if it's clockwise, that is going to move clockwise when we have a high pressure system. Okay, so if we have high pressure, how am I going to explain this? How did I phrase this earlier? Okay, so if we have, let's say, yeah. So high pressure, aka cool air, has air going away. In a clockwise direction. Get this down. Clockwise direction. So if you think about the way a clock moves, right, it's going the same way a clock moves around. And we call this divergence. If I can spell that. Divergence. There's no E in the middle there. All right, so that's what happens with the high pressure. It goes away in sort of this clockwise motion. And then we have the, let me move this here so I have more room here. Talk about isobars in a second. And then we have the low pressure. Or the warm air. Has air coming towards in a counterclockwise direction. And we call this convergence. Okay, so we have divergence and convergence. So let's draw what these look like. Let's talk about high pressure, cool air. So I'll use blue for this. So if I have high pressure, it's going to go away in a clockwise direction. So if it's clockwise, we're going around like this. So we have like that, like that, like that, and like that. Okay? And then, if we have a low pressure, okay, that'd be warm air. I'll use green for this. Red's not working. It goes towards in a counterclockwise direction. Okay? So that means we're going this way, counterclockwise, so it'll look like this. Okay? And because of that, we have sort of these winds that follow kind of this funky path, and maybe you have winds that go out like this, and they go like that, and they go like that, and they go kind of follow this swervy path to get from point A to point B. Okay? All right, so clockwise, counterclockwise, and then we have isobars. So when we look at weather charts, which we're going to do later on, I'll show you a couple today. There's these isobars that are black lines that separate two different pressures. Okay, so on the isobars, it's the same pressure. So it's lines on a weather chart. That separate high and low pressure. Or let me say this, okay, because they're not really going to be that. They'll be pretty similar. Just saying it's like one step up. I'll say different pressures. Okay, so gets a little bit more detailed when you get into stuff like this. I'm not really gonna like drill you on like the nitty gritty of like looking at weather charts and like which way will the wind be going. I just want you to know in general that it behaves in this way because of the Coriolis effect. Okay. All right. So speaking of the Coriolis effect, we already talked about the uneven heating. And we have the global circulation path. It gets warmest here, it goes to the North Pole, and it cools. And on a local level, it does that too, just on a more small. But here we go, we have the Coriolis effect, okay? So what happens is, if air wanted to go from the North Pole to the equator, okay, what would happen is as the Earth is rotating, it sort of pulls it along a curved path as the Earth is rotating, okay? And the other thing, we're not going to do that, is we have these smaller cells, okay? So it's not like air is traveling all the way across the globe. It's really like it has formed these smaller pockets that are rotating in each. Looks like we're in the Hadley cell here, which is between 30 degrees latitude and the equator. It's a pretty big cell, but that's what it is. So our prevailing winds are, in case you're wondering, our prevailing winds are from the northwest, okay? Basically from Canada or from the Dakotas, somewhere in that area. That's where the winds typically are coming from. Not always. Okay, I know today they were coming from like the south, so it's not always the case, but typically that's the way they like to go. Okay, we already talked about rotating winds. All right, these are what isobars look like. Okay, and so these black lines here, all right, these are isobars. All right, they're saying everything along this black line here has the same pressure, so what's inside must be higher pressure, what's outside must have lower pressure. Okay, so they show equal pressure, or you could say that they're separating two different pressures, okay? And it's a bit confusing because normally we say that a standard day is 29.92 inches of mercury. That's Hg, inches of mercury. Hg. But if we're talking about isobars, that's the basically the metric system for that. It is, or it could be, what is it, 1013? I had it written down somewhere. I don't have this one memorized. But it is on one of these pages, 113.25 millibar. Okay, you don't need to know that, but just good to know. That sometimes if you hear about standard day and they say millibar, don't be surprised if it's like in the thousands rather than just 29. Okay, which is why all these numbers are in the thousands. Okay, they're measuring it on the metric system. All right, I think that's about it. Yeah, we're not going to do anything with surface friction. There is more friction with wind on the surface, so winds go slower there. And, okay, we do need to talk about this, all right? We're going to be looking at wind. We won't do it now, but we're looking at wind directions and wind speeds from a map, from some weather charts. And we have some symbols here that tell us, so I would write this down, okay? Maybe you want to draw some pictures with it. That tell us how fast it's going, okay? So if you have a triangle, and think of this like an arrow, right? If we have an arrow, let's see how good of an arrow I can draw. It's telling you which direction the wind is going. So in this situation here, the wind is going south, or it's coming from north, all right? So it's telling you these are the feathers, that's the head of the arrow. That's the way it's going. All right, so here's how we read this. If it's a triangle, that's 50 knots. That's very, very fast. Long line is 10 and the short line is 50. So this would be 35 because it's got 3 long lines and 1 short one. Okay. So write down these: triangle, long line, short line. I think that's about it. Yep, we don't have to worry about mountains too much around here. And yeah, we'll talk about wind shear later. It's a dangerous thing that happens with thunderstorms. And I hope you have a great day. Oh yeah, I'll leave you with this. Every physical process, weather is coming by a result of what causes all weather? Heat exchange. All right, hope you have a great day. And see you later.